Can you see, got that in from there? Can you see from there? Yeah. Okay. Good morning, Morales.
Morning.
All right, so we're on our first warm-up here, Morales, just so you know. So, Baragan, you're all right. Whenever you have hash marks, these little lines on the sides of a shape, that's communicating that they're all the same size. So this is 3 inches, this is 3 inches, that's 3 inches, that's 3 inches. So the perimeter would definitely be 12 inches. But I'm asking for the area. In other words, how many square inches fit inside? And that's what we worked on 2 weeks ago. So the area of a square is length times width. Now, remember those formulas that I shared with you guys on C45 a couple of weeks ago? Right here, watch. Let me go to C45. Where are you at, C45? Here we are. So if you go to C45, the copy that I left for you, you can probably download it to your own computer. The copy of all the formulas is right there on C45, 2 weeks ago, right? Today what we're going to do is we're going to get into three-dimensional figures at the bottom. We're ending the year with 3D shapes. In other words, solids. Okay, we're going from two-dimensional, just flat surfaces, and now we're going to get into 3D shapes. Okay, that's where we're headed today. But I'm noticing the area of a rectangle is length times width. Look, it's the second one down, right here, right? Length times width. So that's the one I'm going to use. So length times width is, where are we at? Here we are. So length times width, the length and the width are the same on the square. Cool. So it's going to be at 3 inches times 3 inches. In this case, it's going to be 9 square inches. Do that. Now today, what you're going to do, before I do the second one on the warm-up, imagine, look what I'm going to do. This is what you're going to get in today. Right now, this shape, before I do the circle, just pay attention to the square here. Imagine if I took this shape and made it, check it out, Catarina. Imagine if I took this square and made a cube out of it. Look at this. I'm now going from two-dimensional figure to a 3D figure. And if I asked you, so we already know that the front face is 9 squares. The area of the front face, this front square, is 9 square inches. Look at, I have it in my hand. It's yellow. So look at, here's one square right here. So look at this one square, Morales and Baragan. There's the one square. Pretend that's the first square that we just took the area of. And now I'm making a cube out of it. Notice, I got a cube, a three-dimensional cube. So we're going from two dimensions flat, just length and width only, flat. And now we're going to three-dimensional. We have length, width, and now depth too. Okay? 3D. Now if I said, okay, what's the area of this now? What would be the surface area of this? Look at it. So it's got 6 surfaces. It has one cube, or one square rather, and there's 6 of them that cover it. 1, 2, 3, 4, 5, 6. So if I ask, what's the surface area of this? Think of the word surface. It's all the surfaces that my hands can touch. The surface area would be, notice there's 6 of them right here. All you in Zoom land. I would take the area of one of them and multiply it by 6 because there's 6 of them. And so we're going to have 54 square inches. That's where we're headed today. The notes you're going to take on the videos are involving two-dimensional figures closed in to make a 3D shape. Okay? That's where we're going. Let's go on to the circle real quick. Good morning.
Good morning. He just wants to finish his last 2 assignments, if that's okay.
That's more than okay.
Perfect.
I've been thinking about them all weekend.
Thank you.
All right, here we go. Let's go on to the second one. So you're on 6 and 7 or whatever.
6 and 7. No.
Oh, 5.
5.
You need 2 credits, right? Yeah, you need 2 credits?
Yeah. Oh, no, I finished 1.
I thought you finished 4. Well, you'll see. You need 6 assignments, right? Because you need 2 credits?
Yeah, last time I checked, I needed 2 more assignments.
Right, because you're finished 4, so 5 and 6 and you're done. 6, that's 2 credits. Is it 2 credits? You sure it's 2 credits? Is that 2.5?
It was 2.5.
Okay, so you're going to need more than 2.
For real?
You have to go to 6, you need 8 assignments. Because 3 assignments is 1 credit. You need 2.5, so you need a little extra than 6. Okay? Here we go. So, the circle is area is pi r squared. Again, I got that formula from the formula worksheets. Now, what is pi? Remember, I kept training that pi is 3.14. What I want to talk about is why it's 3.14. It's kind of mysterious. Let me show you this one video that talks about why it's 3.14. It's kind of trippy. Why is pi 3.14? Watch. Let me make sure the sound's on here.
Hi, welcome to Math Antics. We've learned a lot about geometry so far, but there's one really important geometric shape that we still need to cover, and that shape is a circle. Since the invention of the wheel, circles have been extremely important to all humanity. Grog make wheel. Thanks, Grog. In fact, you probably see circles almost everywhere you turn. But mathematically, what is a circle? Well, in geometry, a circle is defined as the set of all points that are equidistant, or the same distance, from another single point. And the best way to understand what that means is to see it in action. So, here's a single point to start with. And now, let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one, also a foot away, but in another direction, right here.
They're all 1 foot.
Now let's make another, right here.
And another, and another, and another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as the set of points that are equidistant from a center point. But of course, we usually don't see it as a set of points because there's infinitely many of them, so they form a continuous circle. Okay, now let's learn about the parts that make up a circle. First of all, we have the original point that we started with. That's called the center, or the origin of the circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle. That distance is called the radius. The radius is important because it's the distance from the center of a circle to any other point on the perimeter of that circle. And even though a circle only has one radius dimension, you can draw as many radius lines as you want to. Usually you'll only see one radius line drawn since it's the same length no matter where you draw it. Another important circle dimension is called the diameter. The diameter is the distance across a circle. If you start at one point on the circle and then draw a line straight through the center to the other side, that distance is the diameter. As you can see, the diameter is really just the same as two radius lines drawn in exactly opposite directions. So for any circle, the diameter is always exactly twice as long as the radius. All of the equidistant points we drew combine to form the perimeter of the circle. Remember that perimeter is just the distance all the way around a shape. But because a circle is a special shape, the perimeter of a circle gets a special name. It's called the circumference. The circumference is the distance all the way around a circle. we're going to learn how to calculate the circumference of any circle in the next video. We'll also learn how to calculate the area of any circle. But before we can learn those things, we first need to learn about pi. Grog make pi!
So, what is pi? Why is it 3.14? Pay close attention now. Why is it 3.14?
Sorry, Grog, not that kind of pi. In math, the word pi, which is spelled Pi, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? That's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about them. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can...
So now look at here. You got a big circle, small circle, because this goes for any size circle in the world, in the universe. Look at what they're going to do with the diameter, the side that is right in the middle, that goes from one end to the other. How many diameters would fit around the circle? No matter how big or small. How many diameters would fit around the circle? Watch.
Wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference.
So there's one diameter in green. They took the diameter and they're wrapping it around the circle. That's one diameter. Watch this now.
We see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. Two diameters.
So two diameters now. They just took the diameter, wrapping it around. Now we have two. The first one's in green, second one's in yellow.
Still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close.
So the third one's in purple. But look, it didn't completely wrap around the circle. There's a little part left over. Guess how much that part is? 0.14. So this little part that's left over is 0.14 of a diameter, 1400ths.
3 diameters is almost enough, but it looks like we're going to need just a little bit.
What's mysterious is this goes for any size circle. It's 3 diameters and then a 0.14 left over. No matter how big or small the circle is, it's like a mysterious number.
More to form a full
There
circumference.
it is, there's 0.14.
That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small.
All right, so that's where pi comes from. That's the nature of pi. So let's go ahead and find the area of the circle. Make sure that, here we go. So area is 3.14. The radius is 3. Still watching cartoons, Soto? 3.14. So 3 times, remember we always do the second power first. 3.14 times 9. 3.14 times 9, I have no clue. I'm going to bust out my calc. There we go. 3.14 times 9 is 28.26. Watch this now. Square inches. Done. All right. I'm done. You're not gonna take any notes with me today. What we're gonna do